All right, so let's have a look at a question from calculus for you. So the question is, find the domain of the function 1 divided by ln of 2 minus x plus the square root of x plus 1. So I'm going to break this into parts first. I'm going to first have a look at each of these individual domains first. So let's say we call f1 of x to be the function 1 divided by ln 2 minus x. So one thing that we should keep in mind first of all is that ln of x is defined whenever x is greater than 0. Okay, so that's one thing that we have to keep in mind over here, that ln of x has to be defined for x greater than 0. So that means if we're going to be applying this transformation from x to 2 minus x, that would mean that ln 2 minus x is defined for 2 minus x greater than 0, or if you want to simplify this, this would also mean that x has to be smaller than 2. Okay, so that's the first thing. The second thing is that, well, we have to find the discontinuity points where 1 divided by ln 2 minus x is not defined, because there is a point where this entire thing is not defined, which is when ln of 2 minus x is equal to 0. So in order to do so, we have to solve this equation, ln of 2 minus x equal to 0. To solve for this, we have to raise both sides to the e, so that on the left-hand side, the e and the ln will cancel out. So then we would have the 2 minus x equal to 1. And then from here, we would just have to solve for x, so that means x has to equal to 1 over here. So we have the x less than 2 and x equal to 1. That means that there's a vertical asymptote at x equals to 1. So one thing is that, well, x cannot equal to 1, and x has to be less than 2. So that means we could write the domain for f1 of x as follows. So that means d1, which is corresponding to this domain, is going to be from negative infinity to 1, where 1 is the vertical asymptote, or from 1 to 2. If anything is larger than 2, or at 2, this will become undefined as well. Okay, so the next thing is we have to observe this function, the square root of x plus 1. Alright, so let's call f2 of x to be the square root of x plus 1. Okay, so one thing is that, well, the square root of x is defined whenever x is greater or equal to 0. So that means if we change from x to x plus 1, that means the square root of x plus 1 has to be defined for whenever x plus 1 is greater or equal to 0, or x is greater or equal to negative 1. So if this is the case, then we can write the domain for this one. So the only thing that we have to keep in mind is that x has to be greater or equal to negative 1, and that's the only thing. So that means the domain here, let's call it d2, is going to be from negative 1 to infinity. All right. So now there are 3 things that we have to have a look at here. So because, let's draw a number line. And we will observe the values from negative infinity until negative 1, and then until 1, until 2, until infinity. So from here, let's check where the function will then be defined at. Well, one thing we could already note is that at 1, there's a vertical asymptote. So that means it cannot be defined at 1 for sure. If it's between negative infinity to negative 1, well, if we put negative infinity, say we take negative 2 for example, into this becomes undefined, but that is still, this f1 is still defined. But overall, the function will still not be defined. So that's why it will not be defined between this interval over here. at -1, the function will still be defined because x is greater or equal to -1, so at 1, we are still okay. However, between -1 and 1, both functions will still be defined because they share a common interval. So this is where it's also defined. Between 1 and 2, the function will also be defined because they share a common interval. At 2, ln of 2, 1 divided by ln of 2 minus x will not be defined, so it cannot be defined at 2, and anything beyond 2 to infinity can also not be defined as well. So that means the interval where f of x is actually defined is going to be from -1 to 1, where -1 we're including, 1 we're not including, union 1 not inclusive to 2 also not inclusive. And this is the domain where D has to be between -1 inclusive or 1 non-inclusive or 1 non-inclusive to 2.